Hello class, welcome to our channel Helm of Science. Today we will be discussing a chapter from class 12, that is the basics of electrostatics. So let's start. Our chapter is elementary phenomena of electrostatics. This chapter electrostatics cover an important part of every competitive exam as well as your board exams. So knowing this chapter from the grassroots level is very important, and this chapter is the most natural chapter. That means it has the most natural phenomena in this chapter. Okay, so let's start our journey today, and we will learn this chapter by with some examples, some easy stories, or some experiments, interesting experiments. So in the 1600 AD, the Greek scientist Thomas first discovered that if we rub a amber with a fir, amber is one kind of resin of a pine tree, and then after rubbing, the amber attracted this small paper, small pieces of paper, like this is the amber, and if we rub with a fir, then this amber attracts some small piece of paper like this, and this phenomena was very interesting and astonished him. What is happening to this? And after this, he discovered that this piece of amber become charged after rubbing with a fir. And later we saw that if we rub glass with silk, and you can notice that in winter season, if you comb your hair with a celluloid or plastic comb, then the comb attracts small pieces of papers on your table. Or if you rub your pen like this, celluloid pen like this in your hair, and if you touches this to some piece of paper, it will attract those papers. So what is happening, that the celluloid comb and the glass bar or the amber started attracting the papers or some little particles towards them. What is this? This is the attraction force created between the papers and those particles or those materials like amber, glass, and comb. And this attraction leads to the discovery of electrons and electrostatics. That is, the static electricity is generated here in comb and in glass. In Greek language, amber means electron, and from then the term electron was generated. So if we want to know that how this charge is being created in those particles and how it is attracting the little particles, or from where the electricity is generated, this electricity is static electricity. That is, it is not current, it has not current, no current. So it will remain at that place and will discharge itself after some times or some activities. So let's discuss about how this electricity is generated. We know the universe is created with atoms and subatomic particles. Of an atom, there is the nucleus at the center or at the core. The nucleus contains proton and neutron, and at the outer orbital the electrons are orbiting like this. This is an electron, this, and this nucleus attracts those electrons towards its center. If there is many number of orbitals and the size of the atom is very big, at the outermost cell the attraction force over electron from this core nucleus is very less, and this electron, and at the outermost side this electron is loosely bound. So if we rub this atomic particle substance, like this is made of a glass tube, and at this point the atoms are like this and the outermost electron are here, and we are rubbing it with a silk cloth. So by rubbing we can easily detach the outermost electron from this orbiting cell, and thus electron will become free. So what is happening here is here we creating some lack of electrons here. By rubbing, the outermost electron will detach from this orbit and it will reach to the silks, that is the glass. In the glass we are creating some vacancy of electron, that is the glass have some lack of electrons. If there is lack of electron, so we can easily, as the nucleus is positively charged due to the proton and outermost shell is negatively charged due to the electron, so by rubbing, if we are extracting the electron from this orbit or this atom, the atom become the positively charged, and as well as the glass will become positively charged and the silk will be negatively charged by rubbing. This phenomena is known as the electrification by rubbing, and the number of electron leaves glass is equal to the number of electron in the silk which reaches silk. So there is no loss of electron or no gain of electron, the total number of electron are same, but the glass becoming the positively charged substance and the silk is negatively charged. So if we touches glass to some paper pieces, little piece of paper, as these paper are neutral, and this is positively charged, so comparing with the glass, these papers are negatively charged comparing to the glass, but the paper is not actually negatively charged, but in comparison with glass these are negatively charged, and this attracts the glass and it reaches the glass surface. Isn't it interesting? So here comes another concept, which is induction. What is induction? So when we are making a glass tube or a amber rod positively charged by rubbing, and if we place it near a metallic rod, or some piece of paper, this metallic rod is neutral by charge, and also these papers are neutrals by charge. But according or comparing with the glass rod, these are negatively charged. In the next chapter we will learn how positively charged and negatively charged, that is the opposite charge, attracts and same charge repulses. So when we bring this glass rod near a metallic rod or some paper, it will attract the electrons present here. Okay, and as it will attract the electrons, that is the loosely bound electrons, the loosely bound electron will feel the force of attraction and will be here, will gather here to feel that attraction. So this positively charged glass rod is making the metallic rod negatively charged at some instant. The amount of induced charge, that is, this is the induction, the amount of induced charge which is making by the glass rod depends on the charge in the glass rod, the amount of positive charge in the glass rod. So we can easily say that due to the positive charge in the glass rod, the metallic rod is becoming negative at this point. So this is the induction of charge, and this charge on the metallic rod is the induced charge. But these are not the induced charge, these are the charge by rubbing we created. So this is our induction. Now come to another concept or another funny or interesting experiment, the experiment known as the gold leaf electroscope. Experiment. So what is this experiment? This experiment, by this experiment we can decide, or we can identify a charged or uncharged substance, if that substance is charged or uncharged. So there is some experimental setup like this. There is a metallic rod which is bound in a jar, and this is fitted with cork, and the metallic rod, over the metallic rod there is a metallic ball. These all are metal, and at the end of the metallic rod there are two gold leaves like this. Okay, so if we bring some positively charged or negatively charged particles or substance here, and if we touch this substance to this metallic ball, the ball will induced with this charge, or this charge will flow in this ball, and as it is metallic the charge will instantly reach this gold foil and will make this gold leaf charged with this same charge. Okay, so here is positive charge, and here will be also positive charge, and as we know the same charge repels. So the gold foil, at first the gold foil will be like this. This is before charge, and after charge the gold foils or gold leaves, very lightweight gold leaves, will be like this, as they are positively charged and these are repelling each other, so this will become deflected. Okay, and we can easily identify that this substance is charged, and if this is not charged, there will be no deflection in the gold leaf. So then we can conclude that this substance is neutral by charge or not charged. So this is very funny or interesting experiment. Now we will discussing another experiment that is, the charge will always remains or resides on the outer surface of the conductor. Like if there is a metallic ball charged by Q charge, the charge, suppose this is positive charge, the charge will reside on the outer surface of the sphere. There will no charge inside. To justify this phenomena, Michael Faraday set up an experiment, and the experiment known as butterfly net experiment. So there was a butterfly net, and a silk thread was attached to both from inside and outside of this net. So Faraday first tested this charge, and it was neutrally charged by Faraday. So it was first neutrally charged, and then he put some charge here and making it positively charged. Okay. Let's draw a clear picture. And at first it was neutrally charged, and then he put some positive charge here on the net, and he tested with some charge tester like the gold leaf tester or something else. He tested that inside there is no charge, but when he tested outside of the net, there was charge present. And as I mentioned, the silk thread was attached to the end of this net. Then he pulled this net out and making this net like this. Okay. So the outer part is now the inner part, and the inner part of this net is now the outer part. So as previously experimented, that the charge was at this side, suppose this is A side and inner part was B side. So now B side is the outer part and A side is the inner part. so there must be charge on the A side. But when he tested the inner part, there was no charge, surprisingly. And when he tested the B side, that is the its inner side, now its outer side, there was charge present. So he concluded that the charge will resides outer side of a conductor, or the surface of a conductor. This is a very interesting experiment. So how the charge is distributed on the surface? Let, in the simple case, we consider a sphere of radius r, and it is charged with charge q. So total charge is q, and the surface area of the sphere is 4 pi r square. So the surface density of the charge is denoted as Greek symbol sigma is equal to total charge q divided by the surface area 4 by r square. It will vary as the shape varies and the charge varies. So the surface density of the charge is linearly proportional to the, or directly proportional to the total charge, and inversely proportional to the square of the radius. Now we will discuss some property of charges. At first, additive property. What is additive property? Suppose there are some little particles or whatever, each one has a charge, suppose q1, q2, q3, q4, and this is qn. There is in particular. So total charge is equal to q1 plus q2 plus q3 plus q4 plus up to qn. So the total charge is being added. So this is the additive property. Another property is conservation of charge. Charge conservation. As we know, the mass conservation, the energy conservation, that their mass in this universe is fixed, that is transferred into energy, or energy is total is constant, that is transferred into mass. In the same way, the charge is also conserved. Like if we have a metallic ball with charge q, and then we have a metallic rod with zero charge, and if we touch this rod to this metallic sphere, some charge will be transferred to the rod, and the total number of electrons leaving this sphere will be equal to the total number of electron reaching the rod. There is no electron is generated in between, or no electron is distracted in between. The total number is equal. This is the conservation of charge. And the third and most important property is quantization. In the quantum mechanics chapter, you will learn what is quantization, but for a rough idea, I can say that quanta is the minimum amount of something that we can add or extract from that. Like in a jar, okay, another example, like in a lorry is loaded with sandbags. Okay, so if we want to unload this lorry or this carrier, this vehicle, we can remove the sandbags one by one. So the minimum amount of sand that we can extract from this lorry is one bag. That is the minimum amount. And if we load another, if we want to load some more sand in this vehicle, we will add a minimum of one bag of sand. So this is the minimum quantity we can add, one bag of sand. The smaller amount couldn't be, that is the half bag or quarter bag, we cannot add this. So this one bag of sand is the quantum of this lorry, quantum of this sand amount or loading. So this is a rough idea of quanta. So the charge is also quantized, that is, we cannot add something like anything charge, any amount of charge, if to some substance, or we cannot extract any amount of charge from another substance. We have to add or extract with some integral multiple of E, and this E is the unit of charge. And what is this E? This E is the electronic charge. And the electronic charge is equal to 1.6, you all know, into 10 to the power minus 19 coulomb. So this is the minimum amount of charge we can add or extract from a substance, not divided by 2 or multiple, not 0.5 amount of E, not 0.7 amount of E, or neither 4.2 E. These are all are wrong. We can add 4E, 2E, 77E, etc. The integer amount. Now comes some example where the electrostatics is being used in our real life. You all have noticed, must notice, there are some lightning arresters or lightning conductor put over the long buildings or high-rise buildings. And you also have noticed the coconut tree or palm tree are being burnt in lightning. So from that fear of being lightened, we add the lightning arrestor over our house. And the property of this lightning arrestor is it is pinpointed like this at the top. So there are two terms, that is lightning conductor and lightning conductor, and there is lightning arrestor. So these two are different. Now we will learn these two. So the setup of the lightning arrestor is, there is a metallic wire or metallic rod which is put in our building, and it is made little high from the height of the building, and the end is the pinpointed, and this wire is grounded inside the ground with a metallic plate. So when there is clouds in the weather, when there is clouds in the weather, these clouds are positively charged, and the thunder is being on the earth. This is our earth. Okay. So if the thunder, as the height of the lightning arrestor is above the building, the thunder will first find this, and if the thunderbolt occurs, the current will be straight driven to the ground and will be grounded without any harm of this building. Okay. So this conducts the lightning to the ground. So this is the conductor, lightning conductor. And what is lightning arrestor? Lightning arrestor is, as these are the positively charged clouds, these will make the negative charge here due to induction, and this negative charge will make the air negatively charged. Okay. And the negative charge, the same charge repulses each other. This conductor will repulses the nearest air volume and as well as the clouds. So this area is being cleared by this conductor. So it arrests the lightning or prevents from lightning. So this is arrestor. How is this being happened? This is the pinpointed front, and we knew that the conductor resides on the surface of the conductor, the charge resides on the surface of the conductor, and these have the lowest surface area, so the charge will be resides at the top of the pinpointed area. Okay, so these are the main difference between arrestor and conductor. Conductor conducts the lightning to the ground, and arrestors arrest the thunderbolt by induction of charges from the clouds. Okay, so this is the basic idea and the elementary discussion on the electrostatics. On the next class we will learn about the Coulomb's law and all other properties of charges. Thank you.